away from Happy Valley Goose Bay. As of this time, 8:04 p.m., Joanne has not had the baby. I was hoping to be back today, but seems that fate has intervened. Hopefully, boys and girlies, the baby be coming soon, and then I guess I'll be back there and things will be back to normal. But until then, we'll make do with what we got, and here's what we're going to do. We're going to push on ahead. So, here's what we're going to look at today. We're going to look at solving three equations with three unknowns. Now, I mentioned this last day that we were going to take a look at it. I know it's not that easy. It's kind of it's a bit different, but it's not that bad. Need to have your notebooks and your pencils ready and your ears open and your eyes glued on the smart board. Just to let you know, anytime you need to say pause this, you can. I need to get this done in about 15 minutes because YouTube will only let me upload 15-minute videos. I didn't realize that till I had two 20-minute ones done. Anyway, let's get the show on to G.O. Ain't no thing but a chicken wing, right? Now, solving three equations with three unknowns. To do this, we simply follow the same process we did with two equations and two unknowns. Use either one, elimination, and take a look at this stuff and just write it down or whatever. Okay? Boom. Here we got the first system of equations. X minus 3y plus 3z equals minus 4. 2x plus 3y minus z equals 15. And 4x minus 3y minus z equals 19. Same as we did before. We want to eliminate a variable, either x or y or z. Sometimes we need to multiply by a number to get the opposite of the other one in the other equations. Sometimes not. In this case, we've got minus 3y. We've also got a plus 3y. Well, minus 3y and plus 3y, when you add them, they cancel. That's one. And lo and behold, in the other equation, you got minus 3y. So, what can we do? We can say add the first one to the second, then add the second to the third. Easy peasy lemon squeezy. Let's get rid of the y's. Now, so what we do down here, we're going to pair equations to eliminate one variable. Which variable? It doesn't matter. It doesn't matter which variable, right? So look, simply put, we said, let's say this is equation 1 here, and this is equation 2. This is equation 3. We're adding 1 to equation 2. We're going to cancel off the y's. We're adding 2 to equation 3. We're going to cancel out the y's here. Okay? Easy stuff. Add them straight up and down. X plus 2x is 3x. The y's cancel. 3z minus z is 2z. And you got, over here, you got 2x's and 4x's is 6x. The y's cancel, and minus z plus minus z is minus 2z. And of course, add the numbers on the end. Do not forget that. So, when you do that, you have one equation, 3x plus 2z equals 11, 6x minus 2z equals 34. Effectively, what you have created is a new system of equations. It is this one and this one. Here's your new system. What are you going to do? You're going to do elimination again to solve for one of the variables. Which one? It doesn't matter which one. Here what we're going to do is we're going to get rid of the z's. Why? Because you already got a plus 2z and a minus 2z. Simply add them straight up and down. They cancel. What are you left with? 3x plus 6x gives you 9x. 11 plus 34 is 45. Divide each side by 9. You got x equals 5. So, already, boys and girlies, you got one variable found. You got x equals 5. Now what do you do when you live in the shoe, Nicholas? You have to work backwards. Now, how are you going to find the next variable? You have to put this creature in. It's no good to go to the beginning with three variables. You had to plug this into either this one here or into this one here. How come? Somebody should know why. How come? What do you think? Somebody should have said already, there's only two variables. You know one, which is x. You can solve for this creature right here, the z. Good. So sub it into which one? This one or this one? Doesn't matter. Alka Balka. Into one of them. Let's use 3x plus 2z equals 11. The x becomes your 5. 3 times 5 is 15 plus 2z equals 11. Subtract 15 from both sides because you're isolating z. Subtract 15. Subtract 15. You got 2z equals negative 4. Divide each side by 2. Z is minus 2. Now, pretty good. Here's what you do. In order to solve for y, you had to take your x is 5 and z is minus 2 and sub it into either 1, 2, or 3. Doesn't matter which one you use, not even. All you got to do is sub it into one of these to solve for your missing variable y. Put it into which one we're using. Number 2. Put it into number 2 and you get this. 2x plus 3y minus z equals 15. You get 2 times 5, which was your x, plus 3y minus a minus 2 was 15. Solve that creature out, ladies and jelly beans, and you get y is minus 1. Therefore, you got the 3 variables. You write your solution as a point. Solution is at 5, 1, and minus 2. How easy is that, man? That is pretty darn easy. Now, at any point, if you're lost or you got lost along the way writing it down, please just pause me, go back, write it all out, listen to it again. Okay? Simply, you're using elimination to get rid of variables to solve for one in the end, then work your way back to find the missing ones. Okay, let's look at the next example. Boom! Here's what we got. Problem. Use elimination to solve these creatures. Now, you'll notice in this one that the x's, you got a 4x, 2x, 30x, 2y, 8y, and 12y, 2z, 4z, and minus 4z. Label them 1, 2, and 3. If you do that, you'll see that if you add 2 and 3 together, you'll get rid of the z's, right? But 1 and 2 is going to be a little bit harder. Why? Because one is a minus 2z, the other one is a plus 4z. Well, you can multiply equation 1 by what number to get the opposite of plus 4? What number do you have to multiply minus 2 by to get the minus 4? 2. So multiply all of equation 2 by 2 so you can add it to equation 2 to get rid of z. You go down. 2 times equation 1 gives you 2 times 4x is 8x. Plus 4y, which is 2 times 2y, minus 4z, which is 2 times minus 2z equals 2 times 10, which is 20. Ladies and jelly beans, now you add equation 1 to 2. Actually, it's 2 times equation 1 to number 2. Then you add number 2 to number 3. What are you eliminating? Z's cancel off. Look at that. Nice and neat. You add up your remaining x's and y's and your remaining constants on the end on each side, and you end up with 10x plus 12y equals 52 and 32x plus 20y equals 56. Now you simply do elimination again, but you'll notice there's no common number easily found by looking at the coefficients of 10 or of x and y. All you got to do is this. Let's solve the new system. What I did here was I said, okay, you got count by 10s, count by 32. Let's get rid of the x. Why? Because it's just the first one there. Don't matter. All you got to do is this. You got a 10x and a 32x. The first common denominator, or first common multiple, sorry, is minus, or is 320. Well, let's make one of them minus. Let's times by minus 10. So you're timesing all the bottom by minus 10. Why? Because you want a minus 320. Because you're timesing all the top one by 32 to get a plus 320. When you do that, never mind these brackets. They got a mess made. That should be minus 320 minus 200 equals minus 500. or 560. So on top, 32 times 10 times 12 times 52 is 320x, plus 384y equals 1664. And down the bottom, you got minus 320 minus 200y equals 5 minus 560. Add them straight up and down. You'll find your x's go away. 184y. You got 184y is 1104. Y equals 6. You're going to substitute this into either this one or this one, right? Then you'll find what your x is. That's what you're left with. You sub that into, say, 10x plus 12y equals 52. You get x is minus 2. You see right here. Substitute your x and y to find z. Now, which one equation can we use? It don't matter. They use the first one, which you multiply by 2, same equation. You get 8x plus 4y plus 4z equals, or minus 4z, sorry, equals 20. Solve it out. X is minus 2, y is 6. You'll get a creature like z equals minus 3. Therefore, your solution is at what? Therefore, solution is at where? Minus 2, 6, and minus 3. Easy peasy, lemon squeezy, boys and girlies. Remember, this is your x value, this is your y value, this is your z value. Now, if I lost anyone, please go back and look at it again. Don't worry about this kind of one. This one is kind of difficult. I won't ask you anything this bad, but the first one is fair game. You'll get something in between this question and the last question. Don't worry, be happy. If I lost you, please go and take a look. How am I doing for time? I got 3 minutes left because I need to get this up on YouTube. Alright, ladies and jelly beans. Here's what I want you to try. I want you to try these equations, or these systems of equations right here. Solve each one using elimination. You can easily get rid of the y's in the first one. Next one, you got your y's again, or your z's, or your y's in number 4, number 3. It doesn't matter. You say, sir, which one do you get rid of first? It doesn't matter. As long as you go, say, if you get rid of x in the first one, then you're going to be left with y and z. Then all you got to do is get rid of y or z. You're going to be left with either one. Solve, then work your way back. It's sort of like a stepladder approach. Start big, go small, and go out. Not a stepladder approach. Well, I guess it is. It's different steps, right? Whew. Alright, I usually don't talk as fast. But anyhow, ladies and jelly beans, I hope this helped. Work on this for the remainder of this period. Work together. If you need help, by all means, ask your neighbors, ask your friends. Watch this video again if you want. By all means, a lot of good stuff in here. The second time around probably will be easier. Remember, ain't no thing but a chicken wing, okay? And I heard that you were doing well when I was gone. So listen, keep it up. Hopefully I'll see you boys and girlies lately. As of 8/17, no baby yet, Sunday. I hope by this time tomorrow there is a baby. Very exciting down here. Hopefully I'll get back to you guys and girls very soon. Alright, ladies and jelly beans, take it easy. This is Mr. Moores signing out.